Furnaces are used to heat many different types of process fluids. As the process fluid circulates through the tubes inside the furnace, it receives heat that is produced by burning fuel. This particular furnace is floor-fired. The process fluid enters the furnace through these tubes in the convection section. This arrangement allows the fluid to be preheated by the combustion gases before it reaches the radiant section of the furnace. Preheating the process fluid makes it possible to bring it up to the desired temperature while burning less fuel. In other words, it makes the furnace more efficient. From the convection section, the process fluid passes through the tubes in the radiant section. The process fluid becomes hottest in the radiant section because more heat and higher temperatures are available. Regardless of the design of the furnace, the tube arrangement has to allow for a continuous flow of process fluid. For example, these tube ends are connected with tubing bends. In other tube arrangements, the tubes are connected together by enlarged sections of pipes called headers instead of tubing bends. The route that the process fluid takes as it flows through a furnace depends on the design of the furnace. Each continuous, uninterrupted path that the fluid takes is called a pass. This furnace is a single-pass furnace, but many furnaces are multi-pass types. The flow rate of process fluid through a furnace is regulated by valves. There's usually a control valve for each pass. These valves are often operated automatically as part of a control system. The proper flow of process fluid is critical to proper furnace operation. Flow problems can lead to heat transfer problems as well as equipment damage. One type of problem that can occur is called coking. Coking is the accumulation of carbon deposits on the inside walls of the tubes. Crude oil and some other types of process fluids tend to leave carbon deposits behind as they're heated and flow through the tubes. Coking makes the inside diameter of a tube smaller, and it can restrict the flow of process fluid. It can also lead to heat transfer problems. Carbon deposits insulate tube walls, which reduces the amount of heat that is carried away from the tube by the process fluid. If this situation is not corrected, the tube could overheat, weaken, and eventually rupture. Coking can also develop if the burner flames come into contact with the tubes. This problem is called impingement. Impingement can create hot spots on the tubes that can lead to the formation of carbon deposits. If the impingement problem is not corrected, the tubes could eventually rupture. In multi-pass furnaces, the flow of fluid through the tubes can present additional problems. In addition to flowing at the proper rate, the process fluid should move evenly through all of the tubes in the furnace. If the flow is not even in all the tubes, the fluid will not be heated evenly. As a result, the temperature of the fluid leaving the furnace may not be within the specified range. Also, if the process fluid moves too slowly in a furnace, the likelihood of coking and its associated problems could increase. In this topic, we looked at how air flows through natural draft furnaces, forced draft furnaces, and balanced draft furnaces. We also looked at how process fluid circulates through a furnace and at conditions that affect flow through the tubes in a furnace. Now let's try some practice questions on this material.